this video, I'd like to introduce you guys to logarithms. So for the first problem we read this as log base 3 of 9. And to solve this, you can think of this as 3 raised to what power is equal to 9, or the way that I like to do it is just to write it in exponential form. So if we set this equal to x, we can do 3 raised to the x power is equal to 9. So let's write that. 3 to the x power is equal to 9. So this should be pretty simple to solve. 3 to the first power is equal to 3, and 3 to the second power is equal to 9. Therefore, x must equal 2. And we can rewrite this as log base 3 of 9 is equal to 2. So a logarithm is basically the inverse of taking the exponent of something. So say we had 2 to the third power is equal to 8. That is the same thing as writing log base 2 of 8 is equal to 3. These two are saying the exact same thing. So if I were to ask you what log base 2 of 8 equals, this says 2 to the power of what is equal to 8. So this right here is the same thing as this. So 2 to the third power is equal to 8. So what if I wrote log base 3 of 27 is equal to x? Well, we could rewrite it in exponential form by saying 3 raised to the x power is equal to 27. So 3 raised to the x power is equal to 27. So what number raised 3 raised to what number is equal to 27? Well, 3 to the first power is equal to 3. 3 to the second power is equal to 9. And then 3 to the third power, or 3 times 3 times 3, is equal to 27. Therefore, 3 to the third power is equal to 27. Therefore, x is equal to 3. So for our third problem, we have log base 10 of 100. So we could go about this in a few different ways. We could say 10 raised to what power is equal to 100, or we could rewrite it in exponential form. So we could set it equal to x and say 10 to the x power is equal to 100. So 10 raised to the x power is equal to 100. 10 to the first power is equal to 10. And 10 times 10, or 10 squared, is equal to 100. So therefore, if 10 raised to the second power is equal to 100, x is equal to 2. And we could rewrite this as log base 10 of 100 is equal to 2. These are 2 sufficient answers. So what if we had something really large, say log base 10 of 1 million? There's a simple way we could do this. We could say, just like the last times, we could say 10 raised to what power is equal to 1 million, or we could put it in exponential form by setting this equal to x and saying 10 to what power, or 10 to the x, is equal to 1 million. Well, the way we can do this is when we have log base 10 and we have this number right here, starts with a 1 and then has a bunch of zeros after it. All we have to do is count the zeros. So we have 1, 2, 3, 4, 5, 6. The answer is x equals 6, or we could rewrite it as log base 10 of 1 million is equal to 6. That's a very simple way we could do it. I could show you another example just to make sure you guys understand it. We could say log base 10 of, we'll do a smaller number this time, 1000. We can set it equal to x, and then do 10 to the x power is equal to 1000. 10 to the x power is equal to 1000. All you have to do is count the threes. 1, 2, 3, or count the zeros. There's 3 zeros. X is equal to 3. So log base 10 of 1000 is equal to 3. Oftentimes you'll see a logarithm without any given base, and it's actually really easy. It's the same thing. If you don't have a base given or implied, by default it's log base 10. So log of 10,000, since it doesn't have a base, is log base 10 of 10,000. And we can write this in exponential form by setting this equal to x and raising our base, which is 10, to the x power is equal to 10,000. So 10 to the x power is equal to 10,000. Just like the last problem, since it's base 10 and our number starts with the 1 followed by a bunch of zeros, we can just count the zeros. 1, 2, 3, 4. X is equal to 4. Or we can rewrite this as log base 10 of 10,000 is equal to 4. So for our sixth problem, we have log base x of 64 is equal to 3. And at first you might not know how to solve this, but if we treat this just like every other logarithm and we write it in exponential form, we can write x to the third power is equal to 64. And then it might look a little bit more familiar to you. So if we write x cubed is equal to 64, if you're doing logarithms, you're probably at the end of algebra, and I'm sure you've came across numbers like this or equations like this. So if you were to solve this problem, you would just take the cube root of this side and the cube root of this side. The cube root and the cube cancel, and this is equal to and the cube root of 64 is just 4, so x is equal to 4. So for our seventh problem, we have log base 1000 of 1. So we're going to go about this just like any other logarithm. We're going to set this equal to x and write it in exponential form. So we're going to say 1000 to the x power is equal to 1, and that's exponential form. 1000 to the x power is equal to 1. So what number could this be to make 1000 equal to 1? What number could we raise to 1000 to be equal to 1? Well, if you don't already know, any number raised to the 0th power is equal to 1. So 1,000,000 to the 0th power is 1. Pi to the 0th power is 1. So x is equal to 0. So we could also rewrite this as log base 1000 of 1 is equal to 0. So for our next few problems, we have log base 3 of 0 and log base 2 of -1. So we're going to start out with log base 3 of 0 first. And the way we're going to do this is just like any other time. We're going to set this equal to x and write it in exponential form. So 3 to the x power is equal to 0. So what number can we raise 3 to equal 0? Well, it just so happens that there is no number you can raise 3 to get to 0. So this is undefined. So let's go to this one. So log base 2 of -1, we're going to go about this just the same way by setting it equal to x. And we are going to raise 2 to the x power equal to -1 to write it in exponential form. So 2 to the x power is equal to -1. Well, I'm sure you've already guessed it, but this one is also undefined. There is no number you can raise 2 to get -1. So this one is also undefined. And if you haven't already gleaned, as long as your base, 3 in that case and 2 in this case, is greater than 0, or as long as your base is positive, this number right here has to be greater than 0. So, or it'll be undefined. So as long as our base is greater than 0, this also has to be greater than 0. Okay, so for our 9th problem, we're going to get into a little bit more difficult problems. Good news is it's the same steps, they're just a little bit more difficult. So we're going to go about this by writing it in exponential form by setting it equal to x. So we're going to raise 8 to the x power and set it equal to 1 over 64. So 8 to the x power is equal to 1 over 64. And then we can rewrite 1 over 64 as 64 to the -1st power, because if you have 1 over any number, we'll just write x as any number. We can write the denominator up where the numerator would be by raising it to the first power, to the -1st power. And it's basically switching the signs because x has an implied first power here. So to get it up here, we can just switch the signs, and now it's x to the -1st. So we can it'll just make this easier to compare. So we are going to rewrite this as 8 to the x power is equal to 64 to the -1st. So what we're going to want to do here is we need these to have the same base, so we can compare the exponents and solve this logarithm. So 64 can be rewritten as a power of 8. Since we have a power of 8 here, it would be pretty easy to do so. We could rewrite 64 as 8 squared, because 8 squared is 64. So we can rewrite this as 8 to the x power is equal to 8 squared, but we can't forget the -1 here. So all we did is we rewrote 64 as 8 squared, and we kept the -1. So now we need to simplify this a little bit. We're going to multiply -1 by 2, and it'll just be 8 to the -2nd power. So this is going to be equal to 8 to the x is equal to 8 to the -2. And all we have to do now is compare the exponents. We just bring them down. So x is equal to -2. That is the answer to this problem. So for problem number 10, we have log base 4 of 1 over 32. So we're going to write this in exponential form by taking 4 to the x power and raising it and setting it equal to 1 over 32. So 4 to the x is equal to 1 over 32. So just like last time, we need to get 32 to the numerator. So we're going to rewrite this as 4 to the power of x is equal to 32 to the -1st power. And now we need to get these to the same base. But unlike last time, we can't just change this base right here because there's no power of 4 that will give us 32. So we're going to have to change both bases. We're going to have to find a base that we can raise it to a power that both of these have in common. Luckily, 2 to the second power is 4 and 2 to the fifth power is 32. So the common base that we can use here is 2. So we can rewrite 4 as 2 squared, but we can't forget we raised it to the power of x is equal to, and then 2 to the fifth is 32. So we can raise this as 2 to the fifth, and we can't forget the negative 1. And we're going to simplify this a little bit by rewriting it as 2. We're just going to multiply the exponent, so 2 to the 2x is equal to 2 to the negative 5. And now that we have the same base, it's very simple. We just bring down the exponents. So it's going to be 2 to the is equal to negative 5. And this is a really simple problem to solve. We can just divide by 2 on both sides, and this leaves us with x is equal to negative 5 halves. Or we can rewrite this as log base 4 of 1 over 32 is equal to negative 5 halves. So for our 11th problem, we have log base 9 of 1 over 27, and we're going to rewrite this in exponential form is equal to x. So we're going to write 9 raised to the x power is equal to 1 over 27. 9 to the x is equal to 1 over 27. Now we're going to want to get this 27 to the numerator, just like all the other times, just to make this easier to work out. So we can just say 9 to the x power is equal to 27 to the negative first. And now we need to rewrite these bases as a similar base so that we can compare the exponents. So we can't just change this one, because we can't raise the base 9 to any power to equal 27. 9 to the first power is 9. 9 to the second power is 81. But I do see that maybe we could do 3. If we tried that, we could write 3 squared is 9 and 3 cubed is 27. So that'll work. So we can rewrite 9 is 3 squared. I just did that. Don't forget the x power. And then is equal to 3 squared, and don't forget the negative 1. And then we're going to simplify this. We're going to multiply the 2x's, so 3 to the 2x, just multiplied these, is equal to 3 to the negative 3. Now that we have the same base, we can just compare the exponents, and this is going to be 2x is equal to negative 3. And then when we solve, we divide by 2, and this leaves us with x is equal to negative 3 halves. Or if we want to write it in logarithmic form, we can write log base 9 of 1 over 27 is equal to negative 3 halves. Or in exponential form, 9 to the negative 3 halves, 9 to the negative 3 halves is equal to 1 over 27. So for our last fractional logarithm, we're going to go out with a bang. We're going to try to solve log base 16 of 1 over 512. So we're going to set this equal to x, and we're going to write it in exponential form. So we're going to do 16 raised to the x power is equal to 1 over 512. 16 to the x is equal to 1 over 512. We're then going to raise 512 to the numerator by switching the signs of the exponent, which is 1. So 16 to the x is equal to 512 to the negative first power. So now we need, I guess this is just going to be the hardest part, is to find a similar base that we can raise it to an exponent. I know that 16 is we can raise 2 to a power to get 16, and I know that is 2 to the 4th. And I also know that 512, 2 to the 9th is 512. So 2 to the 9th power is 512. So we have similar bases. We just need to, can't forget our exponents up here. So 2 to the 4th, can't forget to raise that to the power of x. And 2 to the 9, can't forget to raise that to the power of -1. We're going to simplify this a little bit by multiplying the exponents. So 2 to the 4x, we just multiplied x and 4, is equal to 2 to the -9. We multiplied 9 and -1. So since we have the same base, we can just compare the exponents right here. So 4x is equal to -9. We can now solve this problem. Divide by 4, divide by 4. This leaves us with x is equal to -9. Or if we want to write it in logarithmic form, we can write -9/4. Cannot forget that. Okay, so log base 16 of 1/512, that's a 512, is equal to -9/4. Either one of these answers is good. So the last portion of this video is just going to be a brief introduction to natural logarithms. And all natural logarithms is just a special type of log where the base is e. So ln of 1 is the same thing as, we can rewrite this as log base e of 1. That's just the natural logarithm. And e is just a special constant in math. It's like 2.718 repeating forever. If you get into calculus, you'll see e a lot. But as of right now, just know it's a special constant. So when you see ln, it's called natural log or natural logarithm. Just know it's the same as log base e. So we're gonna actually solve this the same way as we do with anything else. So log base e of 1 is equal to x, and we're gonna rewrite this in exponential form. So e to the x is equal to 1. Well, we already did a problem similar to this in this video, and if you remember, anything raised to the power of 0 is equal to 1. So e to the power of 0 is equal to 1. Therefore, x is equal to 1. Or the natural log of 1 is equal to 0. Or log base e of 1 is equal to 0. All of these are correct. So let me write a line. It's the worst line I've ever seen, but that is a line. So we're going to do the same thing with this. Ln of e cubed is the same thing as log base e of e cubed. So we're gonna rewrite log base e of e cubed in exponential form, and we're gonna start out by writing log base e of e cubed and setting it equal to x. We are going to write it in exponential form by raising e to the x power and setting it equal to e cubed. So e to the x is equal to e cubed. So if you remember from like just 4 videos, the last 4 videos, we were trying to get the same base so we could just compare the exponents. So since both of the bases are base e, we can just compare the exponents, and x is equal to 3. So ln of e cubed is equal to 3, and log base e of e cubed is equal to 3. That'll be the end of this video. I hope that this has helped, and if it has, leave a like, comment, and subscribe. So thank you.